Hello everyone, this is the TI-84 guy. I'm back. I have a video where I wanted to demo a modification, a change, improvement that I've made to the Alinear program. And I'm going to show you that with an example from the March 2020 SAT. Also, I am going to be doing several videos today of problems from the March 2020 SAT. Some of the problems are going to be, I'm going to be using my program. Some I'm going to be using some test taking strategies, but I'm going to be uploading a bunch of videos today. So let me just jump into this. I started with this image because these are two questions from the March 2020 SAT. These are both linear functions, right? So I am going to do two videos and I'm going to show you the Alinear program. That's my program. I just put an A in front of linear. That's the name of the program. And I'm going to do a video on question 20 and a video on question 21. But I am starting today with question 21 because this is the question that actually shows you the new functionality of the program. All right, first thing, normally when you're asked to come up with the equation of a linear function, 99% of the time, they're going to want it in slope-intercept form, or they're going to want the slope or the y-intercept. And this is slope-intercept form. Y equals mx plus b. M is the slope, b is the y-intercept. Now, what's going on is they've been changing it. Now, some of the times, they're asking you to come up with the equation in standard format. And standard format has this form. ax plus by equals c. And a, b, and c have to be integer values, okay? So that's the only difference. You should be able to go between both of them, but I added this feature to make it a little easier. So now let's actually do the question. It says the equation of the graph shown is ax plus by equals 6, where a and b are constants. What is the value of b? So basically what we're trying to find is the coefficient of the y term. That's what we're trying to find here. So in order to come up with an equation, we need 2 points. And the 2 points are, let me do this. We have right here is 1 point, and here's another point. So the coordinates are 0 and -2. That's on the y-axis. And then on the x-axis, we have 6, 0. Those are the 2 points. Now that we have that, the problem is pretty much done. So now we're going to go to the calculator, my calculator. And I am going to demo let me clear this out because I've got a bunch of stuff here. So let me clear all of that. So the very first thing you're going to see here is I'm at the home screen. Press the program key. Very first program that I have is called Alinear. And the reason that I have it, I put an A in front of it. I wanted it to come to the top of the list of my program. The main reason is that linear functions are by far the most tested functions on the SAT and the ACT. On the SAT, I'd say 60 to 65% of the questions have something to do with linear functions, okay? The next most tested function is the quadratic, and I'd say that's probably like 10 to 15% of the questions. And then the third is exponential. But linear functions are by far the most heavily tested functions on the SAT, which is why I have it showing up at the top. So now all you would do is press enter and press enter again. And here are the options. If you have not seen this program before, I would suggest that you watch one of my other videos where I demo all of the functionality. And I will include a link up here so you can watch it. And I'll also include a link at the end of the video in case you want to go watch it from there. But what we're going to be focused on today is we're going to be using the 2 points option because we have 2 points. And the points are 0 and -2, and then 6, and then 0. Press enter. Now, here's what I changed. Usually, what I normally would do is if you wanted the equation, I would give it in slope-intercept form. But now, what I'm doing is I'm giving you a choice. Which format do you want? Do you want it in slope-intercept form, or do you want it in standard form? In this particular question, we want it in standard form, so I'm going to choose option 2, and it tells me that the coefficient of the x term is 1, the coefficient of the y term is a -3, and the constant is 6. So if I go back to my the question, the answer for this question is a -3. So that's what I got here, a -3. It's pretty simple, okay? So basically I added this functionality. So if you want your output in the standard format, now you can do that simply. Now let me do one more question. All right, so this question is also from the March 2020 SAT. This is a number 36. Now, if you are familiar with the SAT, you know that as you go deeper into the math section, the questions get more difficult. So this is a number 36 question, and there are 38 questions in the calculator section. So this is a relatively difficult question, right? But if you have the Alinear program, this question is a piece of cake. All right, so here we got, I'm writing this up because we've got a linear function here that's defined by f of x equals cx plus d, where c and d are constants. And then they say if f of 50 equals 27,000, f of 100 equals 38,000, what's the value of c? So basically what we're looking for is we are looking for the slope. That's what we're looking for. We're looking for m. Normally, in this case, it's called c, but it's the slope. So what we need is we need 2 points in order to come up with the slope. So here's x, here's f of x. So we're going to have the input is 50, the output is 27,000. The input, when the input is 100, the output is 38,000. All right, we got 2 points. The problem is pretty much done. Now we just go to the calculator and we press enter, and we're going to use the 2-point option again, and the 2 points are 50, 27,000, 27, 1, 2, 3, and then we have 100 for the x value, and then we have 38,000, 38,000, and then we press enter, and we want the equation, but this time we want the slope, so we're going to choose option 1. And it tells us that the slope is 220 and the y-intercept is 16,000. So we would go back to the test and we would grid in 220. That would be our answer. And that would be done, and we'd be going on. So Alinear, I made a change to Alinear so that now if you want it in the standard format, you can get it. But you also still have the option for the SLOPE-INTERCEPT format. So this is a very valuable program, in my opinion. If you'd like to get a copy of it, you need to do 3 things. Send me your email address, make sure it's spelled properly, like the video, and if you would, subscribe to my channel. I am going to be doing a bunch of videos today, so if you guys could also turn on the notification bell when I upload so you can see what I'm doing. I'm going to be doing a bunch of problems from the March 2020 SAT. Some of them are going to be demoing the programs that I've written. Some are going to be test-taking strategies, but I'm going to try to upload about 5 or 6 videos today. So please stay with me. If you'd like to get a copy of the program, just send me your email address, like the video, and subscribe. I will see you guys in a little bit. Stay safe.